We're going to be talking about the whole kit and caboodle today. We're going to be talking about how to get quad files or how to construct quad files if you don't have them, the kind of different implementation strategies from headlocking or not headlocking quads, and how that works in MetaSounds, as well as how to make some things in Reaper. If I have a level like this, where it's a beautiful level where I have all this beautiful flora and fauna, I might want to stack different ambiences together. Now, one of the aspects of doing that might be doing one-shots, and we're actually not going to cover those today. We're just going to be covering quads. The channel layout that we're using here is a quad, which is a front left, a front right, a rear left, and a rear right. Flipped for you guys, but you know, great. Now, there is no centered channel in quad, which is dangerous. You probably don't want to never use a centered channel when you're mixing. You want to be aware that you're using that. But you can see in most environments that we're working in, just having a quad set up and being able to swap back to stereo is really important. So get your patch bay ready or look at whatever monitoring software you're using and work out if quad is right for you. When we're looking into quad and we're talking about quad, it's important to think about the distinction between quad and ambisonic. Ambisonic has height information as well, and that kind of goes up into your 7.1s and things like that as well, a different format altogether. And then we have quads, which is just going to be these 4 channels. If you're on Windows, and it's just probably different if you're on different devices, but if you're on Windows, you can go down to the more sound settings and then right click whatever interface you have and configure speakers. And when you get this, you'll have some options for the speaker layout that you'd like to use. So I have mine set to quadraphonic right now. If I wanted to go up to 5.1 or down to stereo, I could hit test and it'll play out each of the speakers. I can't stress enough how important it is to get your configuration working first. Don't jump into quads thinking that you're going to play some soft bird sounds and that you're going to be able to pick whether it's in the wrong alignment. Getting your speakers aligned first, making sure whatever you're doing first is coming out the speakers that you're expecting is really, really important. In the spirit of that, let's generate some test files. I'm here in Reaper and I have a couple of different layouts here. So you can see I have some test files here, which is literally me saying 1, 2, 3, 4, or front left, front right. Well, I'll just play it, you'll hear it. Front left, front right, rear right. These layouts have the front left, front right, rear right, and that's going to show me that my speakers are configured correctly. If you're playing this back and you find that it doesn't work, you already have a problem. Now, if you're in Reaper and you're hitting play and it's coming out stereo, there's a few things you need to change. Your first thing is making sure that you actually have 4 outputs. So going down to your multi-channel source and making sure that that's set to 4 outputs. This might be dependent on your audio interface, and that kind of goes outside the scope of what I'm going to talk about today because there's a lot of different options there. When you're sending an audio file, because these are just mono files, I want to use the surround panner and I'm just going to hard pan it there. Now to do that, I'm going to check that the input channels are set to 1, set it to quadraphonic, which means 1 in, 4 out, right? And from there, I'm just going to make sure that it goes to the left. Now again, this is just the way that I do things with a stock Reaper setup with no fancy plugins or anything else. You don't have to use it this way. You could move it around if you want to make a slightly different sound, or you want to make it further away, or whatever you want to do. This is just the way that I like to get things set up to begin with. Once we have this sound set up here, we want to highlight and we want to export that range. However you want to do that. For this, I can go master hierarchy, time selection. I'm going to make sure my channels is set to 4, so it actually outputs all 4 and I don't just get mono everywhere. And then I'll end up with a file that I can bring into Unreal. Great. We'll go into Unreal for a second and we'll come back to some of the other elements that I was going to look at in Reaper, like constructing quad ambiences from multiple mono sources and constructing them from stereo buys, or just using straight up surround or quad ambiences is all fine and all very valid depending on what you're trying to achieve. Once we're inside Unreal, there's a few different options for us. First of all, I want to open up a new MetaSound and pop open a quad test. Now, I'm going to do that with us here just to show you the whole process, start to finish. MSS for MetaSound source, then we're going to have quad test file. When we open up this quad test file, there is not a lot here, right? We can even see the single channel that we have on the outset here, and metering is going to be really, really important for us when it comes a time to make sure that we are hearing things out the right channel. I need to stop for a second because my net is driving me crazy. Within my MetaSound, you're going to see I only have one channel, which is not really what we're looking for. We're looking for quads. We need 4 channels. Click on the MetaSound button up here and change your output format to quad. Immediately, you're going to see that you get a front left, a front right, a rear left, and a rear right, or side left, side right. I suppose technically it's side and not rear and left, but you know, whatevs. Now, first thing we want to do is just be sure that we're actually getting sound out of all of our speakers once again. So I'm going to open up a sine wave and just make sure that I'm going to get sound out of all my speakers. Great. Great. Now, if you heard them through all your speakers, great. If you didn't hear them where you were expecting, your front left came out your rear right or something like that, pause the video, go and sort that out, because it's just going to get more and more difficult over time. I've outputted a file that has me walking through each of the channel setups. So to play it, we can use the same wave player that we've probably used a billion times, which is going to be this regular wave player, except instead of using the mono or the stereo, we're going to use a quad. Now, with this, I'm going to hook up the play, and I'm going to hook up each of my outputs. Right, so side left, side right. And for now, I'll hook up the unfinished. Doesn't really matter for right now, but good habit to get into. For the wave asset, I'm not going to use a variable. I don't need one. So I've got a quad test here. Front left, front right, right. And that's the one I'm looking for. And now that we've hooked up our quad test, I expect to hear myself saying front left, front right, rear left, rear right. Front left, front right, rear left, rear right. Okay. If you've got that far so far, great. We're almost ready to do things. One of the challenging things with quads is this idea of permanence spatially. When I'm in a forest like this, where my character is, I want to fill the world with sound and fill the world with, you know, kind of a cool ambience. But if I use quads for this and I do this concept called headlocking, it will mean that they stay with the character. So as the character's head turns, the whole element turns. I can demonstrate this pretty clearly here. If I grab my test file that I've just made, drop it straight in the world, it's going to make a new little audio component. And when I hit play, I'll be able to walk around inside this world. I won't hear anything else except the test file and maybe some footsteps or something like that. Now when we run play, we'll be expecting to hear that just on a loop, talking through its way through the channels. Front left, front right, rear left, rear right. Now one thing that does happen here is if I turn my camera, rear left, rear right, they stay in the same spots. Front right. Nothing actually changes here. Now this could be beneficial. You might want to work this way. You may want to have this for many reasons. You might want to have something that is some blustery winds that you don't really want a person to be able to tell where it's coming from specifically. So as they turn their head, the blustery wind kind of follows them. That's totally fine. You might not want that. You might want the wind to be an important source, or you might say, hey, actually there's an ocean sort of over there. I want the ocean in the quad. I need the ocean to stay in that spot. There's a few different ways to approach this. Either you don't put it in the beds at all. You put it as a point source with a super big attenuation, and that's a totally viable way to do things, but it isn't the point of the video today. The point of the video today is to talk about how do I headlock quads, how do I get them so that they stay on my player or not on my player. To give you an indication of what that kind of sounds like, in case you're looking at me like, what? You've headlocked? I'm totally lost. Great. If I open up this ambience here, we get something that plays out of some of the channels sometimes. If I were to drop this in the world, it would do exactly that. So I'm going to drop this in the world here. So we're hearing it, it's in the world. If I turn my camera, nothing's going to happen. We're not actually playing the game, so that will be the same for when we hit play. We'll be able to walk around. I'm using a new sound here instead of a test sound just to show you the kind of effects. Same kind of concept here, except that instead of the test sound, we have another, some of these birds and stuff headlocked. The same system, but not headlocked, would be to, as the character turns or as the listener rotation changes, we actually rotate the quad back, sort of the other way, if that makes sense. Instead of this headlock quad, it would sound like not headlocked. We should hear the birds that are echoing in one channel stay in that channel. So if I slowly pan around, we'll be able to hear them specifically stuck in one spot. An even clearer example of this would be using a stereo buy. I have here a stereo buy, which is a plane flying past. Okay, and if I hit play and I look at the plane, it should pass one side, so I'm not actually sure where it is. Right, so that passes in front of me, but if I face away from it, it should actually pass behind me now. This makes a lot of sense. It is the point of using quads in this way, to make sure that we always have the sound where we're expecting it to be. It can work with mono sound sources, can work with stereo sound sources, can work with quads. If you want a quad with the beach in one spot, you can leave it there. Out of the box, you get headlocked quads when you do this approach. When you just have a wave player and you hit play, it comes out as a headlocked quad. There is no way to massively change it immediately until you start adding interfaces which take into account things like listener or source orientation. When we grab this source orientation, we get a thing called azimuth, which is going to be the horizontal shift of viewing angle. And if I grab this azimuth and I log, I'll just print it out, and we'll do trigger on value change. We have this headlocked quad. We're going to drop that in the world because we've been using a stereo buy. Drop a headlocked quad in the world, and I'd be expecting to see my values. It'll be somewhere between negative 180 and 180 in terms of the split around me. As I turn my values around, we can see all the way around. Now that is to say that on the left side of my body, it's going to be going negative to the negative side, and on the right side it's going to be on the positive side. We kind of flip that way. But it's also, if you have to think of it in partitions, so it's sort of four spaces. You have forward, back, left, and right in terms of the facing directions of this. Now, cardinally, you have that represented as negative 180 to 0, 0 to 180 on the other side. But when you are trying to think about it this way, you also need to sort of split it into the quadrants if you have it in mind that way. So if I swing around here, you can see it's still positive, and it gets all the way to 0 when I'm facing directly at. If I go all the way around the back, it'll be either 180 or negative 180 in terms of that angle. If I go to the side here, to the right, I'm going to be basically at 90. If I go to the left, I'm going to be basically at negative 90. Great. We have the components here to solve the problem. What we'll need to do is take an angle, look at where it was mapped, and move it to a different quadrant, if we think about it that way, or even just shift it over. So we're taking everything that was 90 needs to become negative 90 if we want to rotate it 180 degrees, which is a simple enough problem when we look at mapping it, but it does feel a little bit complicated when you're looking to route these things. So let's go through it together, because that's the easiest way for you to solve this problem. To do so, I'm going to make these as MetaSound patches. Now, I make them as MetaSound patches because you kind of want to do this a fair bit. I've even gone a step further of making them separate patches just to make the demonstration a little bit clearer, where I have the values of mapping them as one of the demonstration elements, and then I have the actual cross-faded mixes stuff as the other one. You could put them together. You could separate them even more into different elements if you really wanted specifically front left or specifically front right. That's probably a good idea as well, but for now I think we can go through these together. Now, a MetaSound patch is useful because it means that I can open, it looks like this, where I can pass in some values. It doesn't have discrete outputs like a MetaSound source does, in that it doesn't need a play sound, it doesn't need a specific output. We could do a lot of logic, and you can think of them as a decision-making sort of element here. What we want to do is pass in the orientation. If you're looking for something that changes based on height, that's going to be a different element altogether. We're not going to cover that today, but you could use elevation instead. And that would be the elevation of looking down, up or down at the character, in case you wanted to change sound that way. First up, we need to generate these values. We have that azimuth, which is that value between negative 180 all the way to 0, 0 all the way to 180. What we want to do there is generate our forward, back, left, and right in terms of that value of where it should be based on that azimuth. We take our azimuth, so let's say we were at 90, and what's going to happen here is we're going to map the range in two different sides because we need the azimuth of the positive and the negative. Now here we're going to take the range from 0 to 90, this is to say from directly forward to directly right, and we're going to map that as a normalized value between 0 and 1. Then we're going to do the same thing for the other side. We're going to say negative 90 to 0 and map that. From there, we can add the two together, and that's to give us where in that space it's going to be because the plus and the minus are going to sort of balance off each other. And then we can crossfade between the 1 and 0. That's to get it back to exactly the normalized value that it needs to be to turn it up or down, and yeah, crossfade the value to blend between where it needs to be because we don't want to snap it. You're not trying to snap it to a specific position because we might slowly pan across. It might not work for every game. It works for this idea. But you know, great. From there, we basically mirror, well, we're going to get the new value of the forward, or where forward should be based on this azimuth, based on this pointing angle of our current source, whatever's passed in here as well, because it could be listener as well. If you have a sound that needs to change based on the actual source spinning around, it'll be the source azimuth instead of the listener. Great. We have this basically the same approach for all the other ones. So we need to determine the back. Well, we use 90 to 180 and negative 180 to negative 90. We do the same thing. We crossfade between them to work out where behind us our new back needs to be. And then we grab the 0 to 180, or negative 180, which is going to be our left side, and our 0 to a positive 180, which can be our right side. And again, you might be thinking, well, how come it isn't 0 to 90 or 90 to 180? Because these are the hard sides, not the forward and back. The forward and back need to minus off each other because we're kind of taking the left leaning side and the right leaning side, that first 90 degrees, and we're balancing them off to work out where the front is. Whereas we don't need to do that with the left and the right. The left and the right can just be the left side and the right side, being 0 to negative 180 and 0 to 180. I know I'm saying a lot of angles here. You won't really need to use more than these combinations unless you want some finer degree, but the usefulness of panning this way means that you do get something that always is relevant. Now you might be thinking, I can't really tell the difference between these soft bird sounds and these soft bugs and trees, but it is really important to be sure that you are hearing things headlocked or not headlocked as you're expecting. So what we might do here is use our quad test file, which is that front left narration thing that I did, and I'll show you the end result of this so that we can hear, is it staying in the same place? Getting rid of our headlocked file and going back to our non-headlocked file. If I drop in my quad tests, which is our non-headlocked test, and I hit play, we should be hearing our tests first and foremost firing in the right direction.
Front left, front right, rear left, rear right.
Okay, now if I turn a little bit,
right, rear left, rear right.
Right, if I turn a little bit more,
front right, rear left,
we can hear it is rotating around properly.
Front right, rear left, rear.
Now if I line this up with the start of the character, it'll change again because we'll really hear which way it works. So when we drop in now, we should be hearing this front left being on our front left.
Front right, rear left, rear right.
Okay.
Front left, front right, rear left, rear right.
And if I turn,
front left, front right,
now the point of this is that when I turn, the sound needs to stay where it was. So front left should be in the forward front left position of where it was initially. So now we need to work out where the channels, front left, front right, side left, side right, or rear left, rear right, how we rotate those around with a matrix. The matrix here is just 4 different versions of this, and they have slightly problematic thinking behind some of these, in that it's a little bit confusing the first time you do it, but again, you will only set these up once. First of all, we're looking for front left. Now, front left is going to be taking the forward direction, the right direction, then left, then backwards. Okay? We're going to have a slightly different collection of these for each of our front versions based on the value that's going to come out of that azimuth. So to get our front right, we'll need to take left, then forward, then backwards, then right. To get our rear left, we'll need to take right, backwards, forward, left. And to get our back right or rear right, we'll need to take back, left, right, forward. It is really challenging to think of exactly these, but I encourage you to copy these out to make sure that you get your mapping correctly, and then test often. Go back through your system and be sure that your headlock system does work exactly the way it works, or exactly the way that you expect it to work. So opening up your project and hitting play, we should be hearing them in the right positions. Turning even just 90 degrees to the left should result in your front left coming out your right speaker, your front right coming out your rear right speaker, your rear left coming out your front right speaker, front left speaker, and your whatever the other one is, the other speaker. It's a bit of a mouthful to get around. Flipping around to the back, the thing that you should be expecting to hear is kind of a mirror image of the whole thing. So instead of our front left, which would normally be here, our front left is going to be right behind us on the opposite side. And we're going to find our front right is behind us on the opposite side. And then we're going to find our rear left in front of us on the opposite side, and our rear right in front of us on the opposite side. Okay? If you're seeing this behavior, you've pretty much got a non-headlocked quad. This is a stylistic thing that you could choose, and the benefit of it is it allows you to do things like apply this in buys as well. So we could take a buy like this ambience that I have. I've got a stereo playing buy, but I'm only playing it. It only has stereo information, but I'm playing it with a quad, which means these side channels are actually empty. There's nothing happening with these side channels right now. But taking them this way means that we can, well, really, you don't actually need these at all, because we're going to rotate them, because this headlocked quad will always output quad information here. So if I pull it sideways, you can see the quad kind of goes crazy, even though I only have stereo information here, right? But if I go into pan it all the way to the right, this is to say that it's going to be directly behind me. It's going to be in the rear channel instead of the forward channels. It's not going to be there. It's not going to be in the first two channels. It's going to be in the back two channels. And that kind of makes sense. You do need to change that default range variation of the orientation if you want to have a listen to things, but it does give you a pretty good indication of what channel things are coming out of before you even get in game. And it's really important to test this stuff when you don't need to be in game, because once you get in game, it gets a little bit more confusing. We can take the same approach as this stereo output by constructing mono elements. You have something like this here, where I actually have 4 different mono elements that are becoming a quad. And I know there's like spaghetti. Great, the spaghetti makes sense. It's just no real way to do multiple outputs without it becoming spaghetti. But I have 4 different quads from this beautiful Guatemalan jungle one-shots thing that I have. Well, not really one-shots, this beautiful Guatemalan jungle ambience element. And each of the sound sources becomes a mono track, and those mono tracks get fed into being a fake quad. You don't have a quad, which is normal that maybe you don't have a quad ambience. Maybe you just have some wind and some waves and some surfing dreams, right? But if you need to make a quad because you want that quad feeling, then you can always create a quad. You can change your source output to be a quad and then pass in as your front left, front right, rear left, rear right. This is sort of one of the powerful things about MetaSound. You can kind of do away with the formatting altogether and do your own controls. And in this instance, I've actually got a headlocked Boolean switch, so I can turn the head locking on or off. If I grab my orientation and I just put that 180 back in so that we can have a listen, we can fake that the sound is directly behind us. and we can turn the headlocking on and off, which is going to, maybe not drastically, but it does ping the sounds around in different places. Now in this instance, the 4 channels are so similar that there maybe isn't a big difference between doing them, unless a person starts thinking that there are some pygmy monkeys somewhere in a specific direction and that information is important to you. That's kind of when you would want to not headlock things. Now, that switch is really just using our very same orientation values, and instead of going from our sound source directly from these front left, front right, rear right, directly to the output, we're going via some crossfade nodes to say, hey, either take the original of the channel or take the modified version of the channel. Now that's basically everything that I could think of that you would need to know about quads in Unreal, going through headlocking, not headlocking, outputting test files, working out how to pan them in different sound sources or different directions based on no blueprint coding, no complicated maths besides that routing, wonkiness and weirdness. Hopefully this helps a lot. Thank you so much for seeing it and checking it out, and I'll see you next time.